Usharani, BT Assistant, Government Model Girls Higher Secondary School, Mannachanallur. Dear students, can you recognize this picture? Yes, you are correct. The great scientist Sir Isaac Newton. He was the smartest scientist of all the time. He describes the force of gravity. He proposed many theories, concepts and derivations in physics. Now, in this session, we are going to study about Newton's laws of motion. To study the laws of motions, first we have to describe or clear about some concepts of Galileo's. Galileo describes some basic concepts related to the motion. Every body in the earth is in the state of rest or the state of uniform motion. A body in motion will continue to the same state until we have applied an external unbalanced force. We have applied a force to any object, they resist any change in the state. Here, any object in the body to be in two states. One is state of rest or the state of uniform motion. If we want to change the state, we have to apply something. That applying something is known as force. Any object has remained the state until applying the external force. The tendency is known as inertia. Before going to study the laws of motion, we are very clear about inertia, force and the state of an object. Okay, now we discuss about Newton's first law of motion. An object will stay in its state. If it is in state of rest, it will remain state of rest. If it is state of uniform motion, it remains state of uniform motion. In our book words, every body continues to be in its state of rest or state of uniform motion along a straight line. It is to be acted on some external force. It is also called law of inertia, the inability of a body to change itself by its state is called inertia. Suppose if we not apply the force, the object remain in their own state. So, first law also explains inertia. Inertia means inability of an object by itself change its state. So, first law also explains inertia. So, first law also called law of inertia. Examples for first law. The book on the table is remain in state until a person take the book from the table. It remains its state of rest. State of uniform motion. Planets revolves around the sun until an external force is applied. Second law of motion. It is a simple example to collect some idea about what is Newton's second law. Here is the object, say a ball, mass m. Moving with uniform velocity, the speed is known as u. The ball is hit by a car, then the velocity should be changed. The change in velocity is known as acceleration. Before going to study about Newton's second law, we are very clear about these terms. First one, mass of the object is m. Moving with a speed is known as u. Hit by a car, the velocity will be changes. So, the final speed after hit is known as v. The change in velocity with time is called acceleration. Okay students, now we explain what is Newton's second law. Newton's second law of motion. According to this law, the force acting upon a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. It is also called law of force. Once again I repeat, Newton's second law of motion. According to this law, the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and change in the momentum takes place in the direction of the same with the force. It is also called law of force. In our textbook, the derivation of Newton's second law is an important 5-mark question. How to we derive the Newton's second law of motion? Consider an object, say a ball. its mass is m. It is moving in a straight line, the velocity with u. A impact is caused by applying an external unbalanced force. That's why the speed only change. The change in speed is known as v. Here the ball moving with a straight line, so speed is, we use speed instead, we use velocity instead of speed. Okay va? Okay. Okay va varakudadu. Change in speed. Let mass of the object is m. Initial velocity is known as u. Final velocity is known as v. Time interval, the force acting time interval is known as t. What is called momentum? Momentum is denoted by the letter p. Product of mass and velocity gives the value of momentum. So p equal to mv. Here we get two velocities. So initial momentum pi represent p initial. So initial momentum pi equal to mu. Final momentum pf is known as mv. Change in momentum del p equal to mv minus mu. Newton's second law what is told? Force is directly proportional to rate of change of momentum. So del p will be considered as f. Momentum del p equal to mv minus mu. Left hand side we have del p, right hand side we have mv minus mu. According to or in from the second law, del p is also known as f. So f is directly proportional to rate of change of momentum. Here change of momentum is equal to mv minus mu. Rate of change of momentum means mv minus mu by time, or change in momentum by time. So f proportional to mv minus mu by t. Here we remove the proportionality constant. Proportionality we put a constant, it is called k, universal constant. So we remove the proportionality and put k. F equal to k m km v minus u by t. Here the value of k is 1. So if you substitute 1 for k, then f is equal to m into v minus u by t. Hence f equal to ma. In this portion we already known a equal to v minus u by t. A means acceleration. What is acceleration? Rate of change of velocity. So a equal to v minus u by t. So we put a v minus u by t instead of a. Hence f equal to ma. So force is known as mass into acceleration. So we concluded that anything we apply on the object should cause us acceleration. So force is also used as accelerating an object. What do you think to see these two pictures? One is known as balloon, another one is bird is flying. In the first picture there is two arrows. One is known as downward, another one is known as upward. When the air from the balloon comes downwards, the atmospheric air surrounding the balloon pushes the balloon into upward direction. So one is comes out, another one is comes in the downward direction. The flying of balloon to the pushes of the balloon in the upward direction. At the same way, the bird flittering its wings in the downward direction. At the same time, air pushes up the bird in the upward direction. By this equal amount of pushing in the downward, pushing of the upward will remind the birds into flying. So in our daily activities we have defined what is Newton's third law. Newton's third law states that every object, every action, there is an equal and opposite reaction. In Newton's term, for every action of force, there is an equal and opposite reaction. Say A is an force, B is an opposite force, then Fa equal to minus Fb, because Newton's third law applicable only for two different objects. Newton's third law only applicable for two different things. One is positive direction and another one is negative direction. Very good example for Newton's third law is rocket launching. How much amount of fuels are comes out from the rocket? High speed of the rocket is goes into the forward direction.
Thank you, students.